This video will cover section 5.4 of Math 1324. So, last time in class, we were able to start the section and we were talking about the difference with the formula for section 5.3, which was to find the future value or the sum of a geometric sequence. So the difference with sections 5.3 and 5.4 is that in 5.3 we were focusing on finding the future value, and in this section we will be focusing on finding the present value. Both sections are focused on annuities, and instead of future value for this section we'll cover present value. So that is the reason why we don't see the same formula here. And so the present value of an annuity is the amount that must be deposited, let's say today, at the same compound interest rate as the annuity to provide all the payments for the term of the annuity. It does not matter whether the payments are invested to accumulate funds or are paid out to disperse funds. The amount needed to provide the payments is the same in either case. So we're going to begin with ordinary annuities, but we're going to be trying to find the present value. And we started in class, by the way, this was a section we were using in section 5.3, the formula. And if you were in class, we cover example number 1, but I'm going to go over it briefly. So for this one, we had a rate of 4.7, so the rate was equal to 0.047. The payment, it says here, was equal to 200, or 2,000 actually. And we had it compounded monthly. So what happened here, there was a car accident, and the person sued the other person who was at fault, and she was awarded a settlement in which an insurance company will pay her $2,000 at the end of each month. Now, because it is at the end of each month, we use the ordinary annuity. But remember, we're going to find the present value, so for the next 7 years. And how much money should the insurance company invest now at this rate so that they can afford to make all the payments for 7 years once a month and at the end of each month? So we use the formula that we are given here. So make sure you do have that formula on your exam. And remember that for I, we're going to use R over M, and for the variable N, that is equivalent to M multiplied by T. So going back to this problem, we had here that M was 12, and then for the years we have 7. So because of that, we found that N was the product of 12 times 7, and that gave us 84. However, the formula requires that negative sign in front of the 84, so that's what you could see here. And instead of I, we used the definition of it, the rate divided by the number of compounding periods, so this was 0.047 divided by 12 as monthly. And that's what we have here. So when you enter this on the calculator, it will be something like 2,000, and then I will use one parenthesis to include the bracket, and then another parenthesis that will enclose the numerator, and then we could start writing, so it will be 1 minus, and then here this parenthesis will be here, in here. I believe I'm missing one. So it will be 1 plus, and then for the rate, that will be 0.047 divided by 12, close parentheses. We're going to close again because that's what we want to be raised to the power, in this case, 84. So I'm going to enclose that. And that will be this one here, actually. And then we will use the exponent. And right there we will enter negative 84. And now I'm going to close the numerator. And then we're going to use the division symbol. And now for the rate divided by the number of compounding periods. And then we finally close the parentheses once more to close the bracket. And that's how you enter that on the calculator, and the answer should be this one here. So make sure you do practice how to enter things like that on the calculator. So we're going to move on to number 2, and that is about retirement planning. To supplement his pension in an early years of his retirement, Hong plans to use $400,000 of his savings as an ordinary annuity that will make monthly payments for him for 20 years. If the interest rate is 5.2%, how much will each payment be? So we're going to use the same formula to find the present value. It will be payments, bracket, 1 minus 1 plus R over M, close parentheses, divided by negative N or MT, and all of that divided by R over M, and then we close the bracket. So we're going to substitute whatever we have here, and the question here is what will each payment have to be. So we know that at the end of the 20 years, he plans to have a total of 400,000, or no, in fact, that is going to be the present value. So that is what he is going to use to invest and also have a payment, a monthly payment for 20 years. So the present value will be the 400,000. The interest rate will be 0.052. And we're talking about compounded monthly. T is equal to 20. And will be equal to 240. So that's what we will be using here. So now I'm going to substitute what I have. So in fact, instead of the present value, I'm going to write down the 400,000. The payment, that is what we're looking for. And here we're going to have 1 minus parentheses 1 plus 0.052 divided by 12, close parentheses, to the power negative 240. In fact, this parentheses here, I'm gonna close it here. And all of that divided by 0.052 over 12. So what we could do is enter all of this in the calculator. So it will be entered as two fractions. And whatever we obtain from there, we could just divide that, use that as the divisor of 400,000. Or what I'm trying to say is that if we're trying to solve for the payment here, you could see that the payment and everything inside the bracket are multiplying to each other. So to solve for the payment, it will have to be the 400,000 divided by what you have inside the bracket, and it's 400,000. So you will be dividing by the following. By that. And if you enter everything correctly on the calculator, in fact, I'm missing a parentheses here to enclose the denominator, you will be getting $2,684 with 22 cents.